Thanks, Ben. Thanks, everyone. Yeah. Welcome to this. Oh, you hear me breathing. It's always a bad sign. Nope. I try to breathe during presentations. It's a good practice. Jeez, God. Huh. I think that's better. Yeah. You still me talking, right? Okay, cool. Okay, so I've done this a couple of times. I didn't really have the time to update this, so it's still pretty much in the 2018 spirit, as you can see. But I believe it still holds up, so let's see how it goes. As Ben kindly introduced me, I'm Felix. I'm local to Berlin, which is why I managed to be super late today. But yeah, I've been doing this whole ops thing for 15 years now. Jeez, that's scary numbers. I cannot really think about this too much. And I'm always trying to keep my hands busy with open source things. Done lots of Puppet things a couple of years ago. Other things these days, always in the config management scope. And actually, I did come by bicycle today because we're in Berlin and not Belgium, so that's a plus. Okay, let's get warmed up to the whole central theme of this presentation, which is, who has seen this talk? 2 people, okay. You lean back, the rest of you enjoy a little poem. Goes kind of like this. The pig go is to the fountain. The pig put foot, grunt. Food in what? Ketchup. The dove fly is in the sky. The dove drops something. There's something on the pig. The pig disgusting. The pig rattle with dove. The dove angry. The pig leave. The dove produce is chicken wing. With wing bark, no quack. So this very, I think, moving piece of literature, who do you suppose authored this? I did not, but that's a fair guess. Any others? What kind of person might produce this? So rumor has it this is actually the product of an artificial intelligence, machine learning, you know. These days, it's everywhere. Back when this happened, it was not. And there's a little story behind this. So apparently, there were a couple of people who had quite a bit of money, but also had a bit of a problem because they had this IT process where from some third-party source, they would regularly receive some packets of data with any business relevant stuff, you know what, but they never really knew in what format they received it. The third-party application was weird that way, probably some legacy system, so it would produce CSV formats, or you would get plain text binary formats. They never knew, and it was always lots of manual work on the operational side to extract the data of the day. And they wanted to improve that. So the engineers asked themselves, what can we do? And the bosses behind it had the great idea, hey, we've heard there's this newfangled thing called artificial intelligence, and wouldn't that be super helpful? But back in the day, it wasn't really, you couldn't just download, I don't know, Google what have you service to do your things in TensorFlow or what have you. It was really, that was university level shit. So they found an AI expert who was actually some kind of doctor at a local university. And when they presented this problem, they were like, wait, what? This will not be super effectively handled by a machine learning algorithm. You really want to have a kind of script that just gets prepared with all the things and see that it at least works better than the manual thing. But the bosses were really super into the idea and really wanted this AI thing to happen. So, well, expert said, yeah, I guess it's your money to waste, and I mean, sure, why not? Will be fun. So, money was spent, time was passed, systems were built, and eventually the neural network came to life and started doing its things. And well, surprise, surprise, it didn't really work out at all. It was meticulously trained, but very rarely managed to really make sense of whatever data came in because, yeah, fuzzy algorithms are funny this way. So, yeah, I guess that was a bit of a waste. Expert was like kind of, you know, kind of told you so, but what are you going to do? Things were replaced, scripts were written, and in the end, things supposedly worked out. But all the hardware that went into the neural networks couldn't really be repurposed, so it gathered dust in the corner. And apparently, one clever engineer made it so that, hey, if that thing doesn't do anything, let's just train it with some literature and make it write poems. And so legend has it that this very AI wrote that poem that we started with. So the moral of the story being, try and use the right tool for the right job, right? So if you are looking at a kind of problem that is very sharp and requires, you know, I mean, I'm not even gonna open the whole AI debate. That's a good thing. We can have a lunch, but what we of course want to talk about are config management tools, and I don't know if you're familiar with the proverb, when all you have is a hammer, everything looks like a nail, and that can quickly happen when you are like infatuated with your Puppet setup. You try to puppetize everything. On the other hand, Ansible might do poor jobs at some of the things you needed to do. And yeah, let's try to see what the best tool for respective jobs is, because otherwise you may find yourself having built a system one day that tells you no quack. Yeah, hey, in Ghent I was session 2, I think I'm session 3 today, so my bad. Okay, Puppet and Ansible. I guess we are the Ansible crowd today, so maybe if you find yourself in the discussion sometimes where you have this grumbly coworker who's always on about how much better Puppet would be, maybe this will ease it to yeah, have a bit of an objective discussion and take the emotion out of it a bit. Okay, I don't think I need to really sing the praises of config management here. We are all on the same page, right? So we love our repeatable setups. We love infrastructure as code, having source control on our infrastructure and doing code reviews and all the good things. So just to make things a little more plastic and relatable, let's just pretend we are building some kind of web service with the respective technologies. So in Puppet, you would probably create a number of classes depending on your stack, like a class for varnish cache, for the Apache server and for Java to run your application. And there's resources in all these classes. Each resource is responsible to maintain this the desired state on the machines that run the respective parts of your stack. And there's a couple of dependencies between these resources. So Puppet always can tell in which order it should do its work, and also if anything fails, to have a handle on, well, okay, if I couldn't install the package for Apache 2, then it doesn't really make much sense to try and touch its configuration. And Puppet has this algorithm under the hood where it will figure out, or rather, you will have some dependencies that are between different parts of your stack, and these really work on the level of fine-grained inter-resource interactions. It's not that important right now. In Ansible, this will likely look kind of similar. You probably have a role for each of your stack components. The roles have a couple of tasks that are pretty similar to what resources Puppet has. And the dependencies are much more manageable. You may have dependencies between your roles, but otherwise it's the tasks just run top to bottom, and you don't really have to worry that much about what are the specific dependencies between these things. With Puppet, you usually will have this central server that has the code and has all the knowledge, and there's agents on all the machines that you manage that check in and do the things. Whereas, of course, Ansible, you don't bother with any kind of agent setup. You just run Ansible basically wherever, likely some kind of dedicated machine that you choose, but that's really up to you. And that machine has all the information, has the code, and has any additional configuration information in the inventories. Very flexible, you know the drill. So, by the way, if you're not really that in touch with Puppet or never have been, if you do encounter it at some point, there's some naming things that are way off. What Ansible calls a module, Puppet calls a resource type, because a module in Puppet is basically what's a role in Ansible. But Puppet also has a notion-ish of roles in the most prevalent design pattern, and it's comparable with what Ansible uses host groups for, but it's not really that's not really how that works. And yeah, I mentioned that tasks are not a thing in vanilla Puppet. I think they have a product now that also has tasks, but I never tried it. Puppet always thinks about resources in its most basic form. So yeah, and enjoy having discussions with people who don't know Ansible but use Puppet terms for other things. Okay, quick run through what the day-to-day with Puppet looks like. Of course, you write code for your infrastructure, and the data, like in the Ansible variables, Puppet stores in Hira data stores. Hira is basically a tool that lives next to Puppet and manages all the variables. And yeah, it basically implements similar semantics of what Ansible's variables do. So this is what a piece of Puppet code might look like. It's Java-ish. Yeah, it's not much magic. And so this is what the resources will look like. And yeah, it's pretty reminiscent of Ansible task as well, I guess. And the higher variables usually will just live in YAML, so again, should be pretty familiar. There's the counterpart to Ansible's Galaxy is the Puppet Forge, full of modules for lots of things, with a wide range of quality as these things go. And there's this design pattern in Puppet where you group everything in rows and profiles. Let's not even get too deeply into that. There's format integration, which some people like, and there's so classically orchestration would work through this third-party thing, mcollective, which was kind of complex. So I don't have a real diagram of how that works, but just had this mystical unicorn instead. Again, these days I think Puppet has added some products that are more Ansible-ish actually in nature, so probably easier to also orchestrate stuff. But I never tried them and don't know much about them. There's more third-party software like Puppet Board and stuff that give you nice web interfaces into all the things. Yeah, and these are some animals to just give us all a little breather, because that was a lot of Puppet. And now we would look at Ansible basics, but you know, I actually want to do this in another presentation, but quick show of hands, who's actually pretty familiar and feels pretty good about Ansible, uses it daily or has used it pretty heavily? Quick show of hands. Okay, there's a couple of hands. I'm gonna assume some people just don't like raising their hands. This is Germany. German conferences you will not get super great shows. Okay, let's just run through this pretty quickly. I guess most people will be familiar with how Ansible has roles and playbooks to organize the code and pretty elegantly have orchestration next to the separation of concerns in the code. Everything is in YAML, which, well, I mean, it's probably one of the least nice parts about Ansible, but it's what it is, and it's simple. So, what are you going to do? What's really nice is that the playbooks are very structured and very easily tell you what's happening when and where. And yeah, there's the Galaxy where you can download open source code that you can embed in your Ansible variables in YAML. We've been through that, and yeah. Good thing about SSH being it will run pretty much everywhere on whatever Linux things you have running, and even switches and stuff. Yeah, I think we just saw some information about how Foreman supports Ansible, and there's other softwares out there. So when I built this presentation, I would riff a little on how some essential features like log retention and things are not in Ansible itself, but you'd need Tower. Now we have AWX. You saw some AWX in the previous presentation as well, and I will go actually much deeper into that in another slot later. So so that's actually now I feel this is kind of a good thing, and I can tell you much more about that. Okay, so from this vantage, these both Puppet and Ansible are pretty similar when you put them next to each other. They can do similar jobs. So let's talk about why you would make a call either direction, right? Why do we love Ansible, or why can Ansible sometimes be a little inferior? Does happen. So what Puppet really does, and this is a pretty fundamental difference to Ansible's mode of operation. It models systems, and you really try and build this image of, when my config management is through, then it should know what each machine looks like with all the parts. I mean, you always kind of want to know that, but for Puppet, this is really a central point. There has to be this final state, and it needs to know. You need to tell Puppet just how the machine needs to look. It cannot just be, well, yeah, just take these steps and it will be fine. No, Puppet really wants to have the comprehensive view of the things, and it does it by compiling the code that you write into this catalog. There's an actual Puppet lingo term, and the catalog describes all the state, each single resource. What should be this file? What are the permissions on that? And what's the content of this other file? And what version of this package is installed? Yeah, Puppet is very stringent about this. So what this means in a distributed setup is you have Puppet kind of in the center of all your things, and Puppet gets this model. So these little colorful squiggly lines are supposed to be the model of, this is the overall state. So I have 10 systems, I have 100 systems that I'm managing, and by all the code that you write and all the variables that you add to that, Puppet has kind of this image of, okay, yeah, so this goes to that machine, these machines are all of the same kind and they need to look like that. And when all of this is true, then I'm happy, and I have reached this state for my complete infrastructure, and this is now fine. Of course, the machines will, to do that, they will check in regularly. They will send back information, like, okay, this is now my network state, and I have these network shares mounted, what have you, and that can mean that Puppet updates some internal state. Puppet has a database of what's going on all the machines, and if the code that you write could mean that a change of state on this machine on the left leads to a change in the overall model, because some other machines may use the state that is generated from that machine on the left. So next time these machines on the right check in, they will receive a changed state. And this can go on and on, basically. What you really want with Puppet is that you reach a point where there is no further change. So that the ping pong stops and everything settles down. Again, so Puppet is happy when it can reach this final state and has everything under control that's going on. So with Ansible, you think less in terms of, oh, I model my whole thing. It's more like you go ahead, okay, I want to deploy my stack and then deploy my application. So step 1, step 2, go. And once a day, I want to run my, what have you, cleanup job everywhere, et cetera, et cetera. So it's very much action-based, and you just go ahead and think of what do I want to happen? How do I get where I need to go? But of course, still retaining these nice attributes of the tasks are idempotent, and you can just rerun your code. It won't break things, and you can still maintain state that way. Whoops. So yeah, you got your Ansible. Again, from the inventory and variables that you build, Ansible also basically has a model of your network and the machines therein, and will, when you run a playbook that, I don't know, initializes your database servers, will do this based on your model. The thing is, the running state of your infrastructure will not be added to the model as a whole. It's more like, okay, I've just talked to the database servers. They send me these machine facts, so I have some additional information now that I can use to inform the tasks that I'm running now. But when this is through, these are gone. And next time I launch a playbook, I'm going from greenfield, and all I have is what has been added to my inventory variables. So it could just be that you have some complex playbook that really sets up your whole stack with your application and what have you, and what it will likely do is really visit all of your servers and collect the facts and information from everywhere. And now you have this pretty complex model of what's going on. But again, this is really just the right now, and you don't particularly care. You don't need to like have a mental map of, okay, oof, my model has changed, and will I have to run things somewhere else? No. You just write code that does what's right in the moment, right now, and you can rerun it. But it really, yeah, it's really just very dynamic. So putting that all together means in Puppet, you both Puppet and Ansible have this model of what things are supposed to look like, but Puppet really tries to converge the state of everything, whereas Ansible just like you tell Ansible, hey, make it so, and Ansible does the job right now. Whereas in vanilla Puppet, by the way, things can take time. So maybe you run the machines update their stuff once an hour. You can do this, configure this. It might be 2 hours. It might be half an hour between updates on the agents, but it very rarely will. With the classic Puppet approach, it won't be just in time. You can of course use. Back in the day, people sometimes used Ansible just to launch Puppet. That was kind of a valid thing to do, but it just goes to show that control is potentially greater with the Ansible approach. I have thought of a bit of a metaphor for what this means for what these tools do and do it differently. So if you think of so you are basically the producer of some I don't know show on a big theater, and you need to hire a director that makes sure that your show runs great and smooth, and your servers are the actors that perform the play on stage for the audience. And what Puppet does to make things go is you have that Puppet master, which is basically your director, and it's always busy writing scripts, writing custom scripts, and each actor gets a copy of a script, and that script is just for that actor, and each actor just gets on stage and looks at their timings and reads their lines and performs the actions just as it says on their script. And they all do it, and a beautiful play emerges. Whereas with Ansible, it's like you got that guy in the back, and whoever is on stage at the moment, Ansible goes and just shouts at them what they are to do right now. So everyone raise their arm now. Now everyone say, hooray, what have you. And they will all do it at the same time. Once they're done, they leave the stage, and another group goes on stage and get other things to do all at the same time. So as you can imagine, the performance that you can create with either of these approaches will be very different. So you have this, you have these nice choreographies that Ansible will just give you with very little. It won't be a big hassle to put amazing choreographies up, but on the other hand, with the Puppet approach, you will likely have a much more nuanced and quiet and introspective kind of show. It's just different. So all of this is going to say, don't try and push your Ansible into a Puppet-shaped box. What does this mean? Let's get to that a bit later. If really what you need is if you have this one huge playbook and that visits all of your machines and in turn makes sure that all the machines have the right set of packages and the basic, I don't know, SSH configs and hardening settings and what have you. And for compliance, you have to run this whole huge playbook every 2 hours. And since your infrastructure is large, it takes 1.5 hours to go through. That is not a good job for Ansible. You might want to just move that stuff to Puppet. But Ansible has other things where it has huge strengths and will outperform Puppet any day. Some practices that I like to adhere to. Basically, what I just described is this idea of having a site.yaml, and site.yaml having including basically all the playbooks that do all the work for your infrastructure. I don't think this is super helpful to have. I prefer to think of my Ansible code much more in the way of what do I want to deploy now? And if I want to deploy a thing, what should be the workflow for that? So do I set up a new database cluster? Okay, I need one. So yeah, I should run my database playbook. And then I have the new cluster, and I don't particularly care about the web stack that will then make use of the database cluster. I separate these concerns. If I do need a new Apache, what have you, Ruby on Rails, sure, I will run that afterwards. I do not really need that playbook that will also visit all my other clusters and make sure that they are still in the original state. No, this is not what should happen, because yeah, Ansible does not do things super fast, and you really want it to be able to focus on what's on the slab right now. Actually, I'd revise that tags point. Playing around with it more, Ansible tags are actually fine. It's good. Still, again, I really recommend having focused playbooks and not rely too much on, oh yeah, if I do want to just set up a database cluster, then I can just skip these 3 tags and limit things to this other tag. No, I find it much easier to reason about things when there's focused playbooks for the things. And you can also just write a playbook that does something you don't do often. Like, oh yeah, oh damn, we lost this one database server, but we don't have a playbook that will set up just one. We'd have to run the whole cluster thing. But can I? Will this break things on the surviving machines? Oof. Just write a playbook, think of what roles need to run, and do it. It's pretty straightforward in most cases. When coding, we don't repeat ourselves, right? Don't repeat yourself. Copy paste is the enemy because things will drift. But so my general approach is your roles should be responsible for things, and you shouldn't have copy paste among roles. And should really try, okay, focus the role, make the role flexible. On the playbook level, that doesn't apply at all. Like, you do not need, okay, I have my common role, and the common role takes care of all my basic needs on all operating systems, and there is this playbook common everywhere that will run this role on all my machines, and if I want to run the common role, then this is the playbook to do it. No. Rerun roles wherever you need them. It's totally fine. If you have a couple of roles that show up in every other playbook, who cares? It's that's really what the whole role approach is about. It's fine. And yeah, you will find a couple of best practices in Ansible documentation, and many of these are actually really good. Some of those I found I do not agree with at all, and they make work harder for me. So I just advise everyone to think critically about, is this advice really for me? Some just aren't. Spoiler. So just to drive that home, I try to make a little animation of what this site YAML approach will look like in your infrastructure if you go with it. What it will typically do is contact all servers and gather their facts, and then it will probably include some playbook to set up the, I don't know, first probably storage or database servers, and then some kind of, I don't know, load balancer or queuing service, then your application servers or what have you, and I don't even know what these are, but I'm sure you need them. And yeah, so this probably was a Ansible run that took like half an hour, and doing it again and again because one task broke, yeah, it's just not fun. Rather, what you want to make your playbooks do is orchestrate things and do things that make sense in order, and that's where Ansible is strong. Like, okay, sure, there's something I need to do everywhere because I need it everywhere, like SSH. But sure, as soon as my database is basically there, I can go ahead and initialize my web stack, and these run in order. And since then I can immediately deploy the application, which, by the way, is a separate step because this is one that you will likely repeat over and over, but it doesn't require you to run the whole site YAML. This should really be something that you have modeled in a step that you can run on its own. And to then initialize everything, there may be complex things that are going on, right? You run a script on this central API service, and it sends some piece of information to these others, and you run your database migration script all in the right order. Ansible knows what to do where, and you just write that code down. It waits. It works just very organically. And when Ansible will be able to wait until whatever initialization scripts have finished, and then can continue and activate your deployment for the users, etc. So in the end, Ansible really allowed you to do things in a sensible order, in a fashion that is, that's natural, that is modeling what you would do with your hands if you would not have an automation tool. I think which is nice, and which really is what makes Ansible in many contexts so much preferable over other automation approaches, and why we love it so much. Okay, so going back to, okay, you have this discussion with colleague X who likes whatever other tool so much. So this is basically my own guideline on when do I choose what to do with which tool. So Ansible, in comparison to Puppet, super good when you need to deploy actual applications. That's what is great. I think it makes it super easy to also manage network infrastructure. Puppet will do it, but it's a little more awkward. So Ansible is very good here. When there's things where you want to do just-in-time things through your infrastructure, again, Puppet has now additional tooling to mimic Ansible's approach, but Ansible has this is just Ansible's MO. If you have Ansible, then you will very handily do things in your distributed system. Do you have Python everywhere on your systems, but you do not need Ruby for anything? Well, in that case, Ansible probably better choice, because if you want Puppet, there will be lots of Ruby. I'm not sure how true this is anymore, because Puppet has been moving things to C++. But yeah, that definitely used to be the case. I'm a little out of touch. Okay. Again, there will be situations where Puppet might actually be better. If you're Ansible, if you find that Ansible has been running always through all the systems and just tweaking some basic settings that have to be the same everywhere, Puppet might make a better job of that. Puppet is pretty strong when there's a wide range of operating systems about. It supports some things that Ansible just doesn't. And of course, you can build Ansible code that will behave on, say, a Red Hat versus Debian systems. Still do the right thing everywhere, but it's a little more strenuous, I feel. So Puppet has some elements to it that make it super powerful in terms of automated testing. You can build on the central Puppet services to have amazing additional tooling. It's really a powerhouse that way, but setting it all up and maintaining code, Puppet code, it takes away from simplicity, and I think there's great value in simplicity of your automation setup. So that's trade-offs all the way down. And yeah, again, if Python is not the thing you want to contend with, because Python, especially seeing with the divide between Python 2 and 3, it's not great. So if Ruby is already on your machines, but Python is not, you might have an easier time going the Puppet way. But so with all other things being equal, right? I found that at scale, Ansible is not fun. I mean, I never made huge efforts to try and scale the Ansible executor, but rule of thumb, if you have playbooks that address large numbers of machines, it will be slow going. If anything along the way has mysterious failures, it's no fun because you have to clean up. Yeah, so at scale, I think Puppet may still have some advantages. So does it make sense to have both Puppet and Ansible running? So in general, yes, because I hope I brought this point across. There are scenarios in which Puppet just performs better and makes your life easier. So you can put it underneath Ansible, but if you really don't have any expertise in one, but like have great people at the other, then it's probably better to just make do with the one tool and everyone is comfortable, because they are really both quite powerful, and for most simple automation requirements, they will both do a very good job. So I won't tell you, hey, go home and add Puppet to your setup because it will make some of your things easier. No, having one tool and allowing your team to focus on one code base has a lot of advantages. So closing out with how should we lead this discussion if it comes up, if you have the person on your team who will always mumble and grumble about the tooling of choice. Well, my general approach to this is to be compassionate, and if you let emotion get into it, it should be positive and not so much anger. I think that is what we should strive for in this whole space. Okay, that's it. Do I have any extras? Oh yeah, my employer is hiring. We're in Berlin. We are also in Vienna and Frankfurt. And I mean, you're at the conference. I suppose every one of you has a gig going, but maybe you know someone who is looking for a change, or I don't know. Keep in mind, check out our openings. There's a lot of them. Range of roles. Check us out, maybe spread the word. Thanks.
Thank you, Felix. Are there any questions? Okay, I come over.
You mentioned Puppet has some benefits over Ansible when scaling to a larger number of machines. Could you put a number to that allegation?
So I don't have super good numbers. The thing is that with Puppet, you will absolutely scale the central service. So if your infrastructure grows and you have 1,000 agents or 10,000, you will be adding more Puppet masters, and they can distribute the load, and supposedly that works very well. I don't know where the limits are here. There's Postgres in the database backend, so I mean scaling that is probably less fun, but it will also work. So no, I don't really have numbers. I do know that say a normal Ansible runner with a sufficiently complex playbook can already be strained in like the dimensions of 100 or 200 machines that it's trying to run stuff on. Again, I didn't really try my hand on scaling this in any fashion, but if you try and keep it simple, you can run into issues pretty fast, I feel.
So, do I understand that correctly, that we could, well, let's say, look out for a threshold somewhere in the 3 or 4 figures?
I suppose, again, I'd possibly defer if anyone has experience how you go about actually scaling Ansible. Torsten raises his hand. I'll actually, I joined this discussion in the hallway track because that's interesting to me as well. Or maybe if you want to add something right now, I don't know if there's other questions, but
So scaling Ansible is completely different from scaling Puppet, first and foremost. Typically, most Ansible users start complaining from about 200 hosts. That has been my experience. I've been following the project since 0.2, so I've been doing it quite a while. The main problem is the SSH overhead. There are ways to avoid that, so you can do pipelining, you can do socket controls. You have now Mitogen that has come up, which isn't core Ansible yet, but it helps you scale much more. So typically, if you have none of the optimizations, you will complain from about 200 hosts. With optimizations, you will get up to about 500 hosts, and with Mitogen, you should theoretically get to about 10,000 hosts. But Mitogen is a pain in the ass for the moment because Ansible, so core Ansible doesn't support it. It's DW, I forget his real name, who supports that on his own without any help from the official upstream Ansible. So it works well, but it's still very early stages. So, but scaling Ansible is a completely different problem.
so let's all write mails to Red Hat and ask them to do something.
Well, I'm working for Red Hat, but this is not a Red Hat statement. It's a private one. I used Puppet for a long time, and I now use Ansible. I find the best way to scale is to not have a central controller. Just deploy Ansible locally, have it run with a cron tab or whatever. And the good thing is that if it fails, it just can send you an email or whatever. And if you have 10 machines, you have 10 separate processes, it's scaled naturally. You just build more machine, more process. And that's how I will achieve, like if you have a large environment, just have that and have Ansible send the report to some kind of central manager. This way you just offload the load. And of course, as you said, like SSH connection, all of that, if you have a central controller, you have a single point of failure. And this is a mess to scale. And having this kind of distributed system is easier. Again, not a Red Hat statement. Yeah, this is why I'm saying it again, not a Red Hat statement.
What was your name?
The Red Hat statement, I can't say my name. The Red Hat statement will be, please call Red Hat, we have probably a solution for that.
But it's of course a good point, like sharding like in database is probably a good idea if you can get away with it with Ansible, yeah. Yeah, I can see that.
Okay, the hallway track is always open. So again, thank you very much, Felix, for that great talk. Thank you.
Thank you.